This is an introduction to data management for researchers. On behalf of the Virtual Data Collaboratory, a joint project of Rutgers University, Temple University, and Penn State University. I'm Ryan Womack, data librarian at Rutgers University, and this presentation is based on content originally generated by the contributors listed on this slide. We're going to present a brief overview of data management to give you an orientation to that landscape. So let's start by asking, why data management? Data management is useful to organize your work, to preserve that data involved in your research for future reuse, both for yourself and others. And data management can enhance the impact of your research, the credibility of your research, and enable future collaborators, people working with you, working on your projects, and even your own future self who may need guidance on how to use the data that you've created today in a future work. So we'll talk about how we can achieve that coming up. So let's start with just some basic practices when you're working with your own data. You want to think about your raw data as a precious object that cannot easily be recreated, and certainly once you've used it in your own research, you want to make sure that you're able to refer back to the original version of your data. So keep your raw data pristine. Keep it in a separate directory. Keep it read-only. Keep it away from any working intermediate steps that you use your data for. As you work, you should document your variables and your data collection. It's much easier to write things down as you're doing them than to reconstruct them later when your memory may be faulty. There may have been a lot of intervening things that have happened. So write down not only your documentation, but anything you yourself might forget. If you think 3 years from now, 5 years from now, am I going to remember this? Write it down. That's exactly the kind of information that others will need as well when they turn to use your data. Also, if you can, don't work in a tool like Excel or some other environment where you're editing the data manually. It's difficult to remember the steps that you use to delete a column, to transform a variable, when each of those things is a manual step that's not tracked by the software. If you use a coding environment such as Python or R, that's going to be a way that records your steps, and certainly lots of other tools have means that can be used to record the steps used in your data. Code is certainly preferable. Let's talk about how you can organize your projects. So for a small project, a local project, sometimes it doesn't seem that the file organization is useful. However, it becomes more and more important as the project gets larger, the more it's shared with others, and the longer period of time that you're going to be using that. So at the beginning, it's nice to have a file naming convention that's structured, it's meaningful, that includes into the file name things like the date of collection, the location, the method used, the subject of the collection, so that you're not relying on other secondary metadata or secondary folder organization or secondary file timestamps that might be changed, that are all things that might be encoded into the file name itself. You should also make sure that your directory structure is logical and well thought out. So have a folder for your raw data. Have a folder for your modified data. Have a folder for your code. Have a folder for any outputs that are generated, graphs or reports. Keep those separate, and setting up your directories that way in the beginning will be a great way to keep your project organized as you move forward. It becomes much easier to communicate that data to others, to make sure that scripts are running in the appropriate places, and lots of software tools have utilities or packages or add-ons that will guide you through this process of setting up a structured directory. So those are all practices that help you when you're working with your data. When you think about beginning the process of data that's going to be shared or viewed by others, and that's increasingly important in today's world as people want to know, how were these results generated? How can I reproduce these results? The critical thing for that is going to be your documentation. So think about what someone else would need if they just pick up your project to start to use it themselves. So that could be a README file that simply explains, here's where the data is, here's where the code is, here's the things that you need to have pre-installed on your system for it to run. A code book, in many fields, a code book is a standard practice where the code book has each of the variables explained, how the data was marked up, which codes were used to record which characteristics, and possibly some of the judgments that were made in deciding how to code a variable one way or another. Codebook is a great place to lay all that out and explain to people what your data is about. Again, if you do this in the beginning, as you're setting these things up, as you're initially working, it's much easier than to try to go back later and recreate that. Also, another critical part of data management is, of course, keeping your data safe. So you want to think about having a good storage and backup process. There's a very simple rule called the rule of three that you should be aware of, that a file is not safe unless you have 3 backups, 2 locations on site and 1 that's off site. So it's fine to have that hard drive copy, but think about if some kind of event wiped out the data in a particular location. There are fires, there are floods, there are things that happen, or the data can be just corrupted in one location. So think about multiple strategies, and at least one of them in some remote location, a cloud backup. However, keep in mind that when you're backing something up to a cloud, you want to make sure you have a complete backup solution. There are tools that do that. Syncing tools like something like Dropbox is not backup. Think about it for a moment, because if something comes and corrupts the files on your system, or you accidentally delete something that you shouldn't have, you are going to replicate that to your synced up backup. And while it is true that you can revert some versions online, that's not really as reliable as having something that's a pure backup. Also, when you're thinking about the future, think about future usability, think about open formats for your data. Don't depend on one piece of commercial software that even if people have access to that software in the future versions might not be backward compatible sufficiently, or might introduce some uncertainty into your data. So I for one always prefer sort of flat file types, very simple things like comma separated CSV files for data, or something that's very standard, very open for your discipline. Okay, so you have documented your project, it's well organized, it's all backed up, everything looks great, and now you're excited about your data. You want to share it out there so that others can see what a wonderful job you've done with your data. Where can you share the data? Well, there's not a simple answer to this question. However, there are many tools out in the world that are designed for data sharing. So we've listed some of them on this slide. You can get a link to the presentation slides themselves and follow up those links. These are websites, large-scale projects that are designed for data storage and data sharing, and make it easy for you to create an account and upload your data. And of course, the Virtual Data Collaboratory itself is a place for this kind of data sharing. The Virtual Data Collaboratory is designed to enable people to collaborate on projects, work together with data. It is not explicitly designed as a long-term storage or long-term sharing solution. However, it's part of this ecosystem that also includes many major open data sites, data portals, data projects, and of course, you want to check the ones that are most appropriate for your discipline. And so I would highlight on this list ResData or RE3 Data. that is a tool that actually lets you look up the repositories that are appropriate to different disciplines. And if you have questions about that, that's definitely something to consult with the data management team at your institution about. Okay, so you have now gotten your data out in the world, and now we want to talk about ways to ensure reproducibility of your data. So again, a goal of the VDC is also to enable reproducibility by making all of that code and data available on the one shared site. That's one way. However, you also want to think about making your data available in a form that anyone can pick up and use it. They don't have to be a member of a particular portal or a particular site. So you want to set up your data in an open way. You want to share it on a widely available platform. Of course, things like GitHub are out there. GitHub, of course, a commercial project, but so widespread and widely adopted that it's quite easy to find a lot of open material on GitHub. And GitHub, of course, is designed for code sharing in particular. So it's a great place to make sure that the full versions of your code that run your data are out there and available. And there are many other tools that let you do that. One thing you want to think about is getting something like a DOI, a digital object identifier, for your data. That makes it easy to cite. DOIs are commonly used for journal articles these days, but they are also used for data, and many, if not most, or in the future, I hope all of the data repositories that we're recommending will actually generate a DOI for your data when you deposit it. So with the DOI, you have a permanent, easily citable and trackable link to your data. People can find the exact data set that you're talking about, not have to wonder which of these Google search results is the correct one to use. And if you package it together with your code, and your code is well explained, well commented, well documented, using literate programming techniques, which we won't go into, but that's definitely something you want to consider, you will give the end user a great package that will enable them to see exactly the data you used, how you conducted your research, and to confirm and extend your results. So if you follow all of these data management practices, that will ensure that your data is fair. Now, FAIR is an acronym that stands for findable, accessible, interoperable, and reusable. The FAIR principles are increasingly promulgated as goals or targets for many data initiatives. So it's a great short way to think about what you want your data to be. You want it to be findable, right? Share it in a easily discoverable repository for your discipline. Use something like a DOI to identify it. Make it accessible. Make it clear if there is any restricted data as part of the things that you worked with. You can also make that clear in your documentation and your READMEs and your explanations of what you couldn't share. But of course, for others to adopt and see your data for the maximum impact, more accessibility is desirable. You make your data interoperable by making that code available, by using open formats, by using tools that are easy for others to access and work with. And you make it reusable by the entire ensemble of these good practices, that the data is all there, it's easy to understand, the code is there. And if you work through your whole process with that in mind, it has benefits for you as a researcher. Your results will be easy to verify and and viewed as more reliable. You will be able to work with your own data in the future much more easily, just with a little bit of upfront investment. And others will see that your data practices are top-notch, and they will value your research more highly. They'll be able to cite it and use it and that's going to have a positive impact on your research future, and also the larger research environment will have better research. And that is really what this is all about, and what the Virtual Data Collaboratory is also trying to support. So that's a brief overview of data management. Hopefully that gets you interested in learning more, and you can visit the Virtual Data Collaboratory site or some of the links in these slides to learn more. Thank you very much.